Hey, this is Mike. Welcome back to part 2 of this video. In this video, we will be talking about concepts that allow you to level up your skills in solving multi-step linear equations. But before we start, let's quickly go through what we have learned in part 1. Please look at the following 4 equations and can you confidently solve them? You may pause the video and try, and I'll give you the answers shortly. Just in case, if you've got any of them wrong, please go back to part 1 of this video. I'll provide a link on the top right of the screen. It covers the fundamental concepts that allow you to solve these equations confidently. So please take your time to make sure your fundamentals are sound. If you're staying, I'm sure you know these are the 4 basic options we have in solving an equation. Now we want to expand our options to solve more complex equations. We know that we can do these operations with numbers like 3 and 7, but can we do the same with an unknown? Say, can we add x to both sides of the equation? I want to give you a perspective that you may not have heard before. In Chinese language, algebra is known as 代数 or 代数, which is roughly translated to substitute for numbers. In other words, it is a number. We just don't know what it is yet. If we look at it that way, an unknown is also a number. We shouldn't be surprised that what we can do with a number, we can do the same with an unknown. Now that we know what we can do, but when are we going to do it? That's the question. First, we look at equations where addition is involved. We have 2 equations here, x plus 1 equal to 4 and 1 plus x equal to 4. They look different, but in reality, we can solve them exactly the same way. The next pair of equations will involve multiplication, in particular 4 multiplied by x. Regardless of the order, we solve them exactly the same way too. These are not the situations where we need to be cautious about. Let's move on to the next examples. Here, we are considering equations that involve subtraction. Over the years, I've seen students failing to see how different they are. The left equation is solved in 1 step, but the right one is not. It is actually a 2-step equation. In a similar fashion, when the equations involve division like this example, the left one can be solved in 1 step by multiplying both sides by 4. However, even if we divide the right equation by 4 on both sides, we are still not getting the solution yet. What I want to highlight is whenever you see an equation that involves subtracting an unknown or dividing by an unknown, be extra cautious. I have prepared 2 worked examples on each scenario. Let's go through them. In the first example, the equation has a part that says 1 minus x. Just like I said, be extra cautious. First thing first, we treat 1 minus x as a new unknown. Divide both sides by 4 and we get 1 minus x equal to 3. Here, allow me to show you a common mistake I've seen over the years. For unwary students, they simply subtract 1 from both sides and get x equal to 2. However, if we look closely, the unknown terms on each line don't match. It should be negative x equals 2, not x equals 2. One of many ways to correct this is to add x to both sides of the equation and get 1 equal to 3 plus x. The rest is pretty straightforward. The next equation may look familiar to some of you because it appears a lot in ratios. Some people might say this is not a linear equation, but let's ignore that for the moment. To solve it, we can divide both sides of the equation by 3 and get x equal to 2 over 15. But this is wrong. I was just showing you a common mistake I have seen a lot. The reason why some students made this mistake could be the way the operation is explained. Sometimes we hear people say 3 divided by 3, the numbers are cancel. The concept cancel is a handy way to say when 3 is divided by 3, it becomes 1. Sometimes 1 can be omitted and it looks like the original numbers are cancelled. To give you another perspective, if we change the way the equation is written, we can see that there is 1 over x all along. Let's try again, and one way to solve this equation is to multiply both sides by x and get 3 equal 2 over 5 times x. Next, we only need to multiply both sides by 5 over 2 to get the answer. To sum up, when you see equations that contain subtracting an unknown or dividing by an unknown, it might be beneficial to add or multiply both sides of the equations by that unknown. Are there other situations we might want to do these operations? Definitely. And that is the second half of this video, where we will see unknowns appear more than once in each equation. Before we begin, can you tell how many terms are there in each of these 4 expressions? It's an important question. Please pause and try them out. The answer is, before combining like terms, each expression has 3 terms. After combining, each expression has 2 terms. If you answer perfectly, feel free to skip ahead to where the actual solving begins, or you may allow me to illustrate why that is the case. Let's go through them in pairs. In a nutshell, terms in polynomials are separated by addition sign or subtraction sign. Using the first equation as an example, when we expand the expression, we have 3 terms that are 4x, 4, and -2. Since 4 and -2 are both numbers, they are like terms. We can combine them, and that leaves us 2 terms. In a similar fashion, we expand the second expression. 2x and 3x are both x terms. We combine them, and it leaves us 2 terms as well. As a quick reminder, do not combine terms that are unlike. For example, 4x plus 4 is just 4x plus 4. It's already the simplest. Now we will put the 2 expressions together and make it an equation. We can see clearly that there are 2 x terms, one on the left and one on the right. The key is to combine them. To do this, we subtract 4x from both sides of the equation in one step. We have changed it back to a basic equation, and the rest is straightforward. I haven't forgot the other 2 expressions. Let's go through them. For the left one, we first divide x and 1 by 3 respectively, and we can see 3 terms. Like the previous examples, we can combine 1 over 3 and -2 to get -5 over 3. In the end, we have 2 terms. The expression on the right is slightly more complex, but we can go through a similar process to see that in the end, we also have 2 terms. If we put these together and make it an equation, we can solve it like the previous example. However, I would say a lot of students have a hidden fear about fractions. Therefore, I would like to present to you a useful technique whenever you see fractions in equations. For this equation, we look at all the denominators, which are 3 and 9. Next, we asked ourselves, what is the largest common multiple of these 2 numbers? The LCM is 9, so we will multiply both sides of the equation by 9. Basically, after this step, we get rid of all the denominators, and for many people, this is a much more preferred equation to solve. I'll show you the rest of the solution. Towards the end, since I'm running out of space, the steps are a bit more concise than usual. Hopefully it doesn't cause any misunderstanding. To conclude, whenever we see the unknown appears more than once, we have to identify what the unknown terms are, or X terms in most cases, and then we combine them. If you do it right, at some point of your solution, the unknown should only appear once. If you stick with me throughout part 1 and 2 of this 2-part video, congratulations, and I hope you have learned something. To be honest with you, I took a rather unconventional approach than most other YouTube videos. I talked a lot about the fundamental theories and concepts. I intend to give you some rules that could be challenging to grasp at first. But once you understand that, you are in a very good position to progress to the next stage. When I teach, I don't simply focus on getting students ready for the questions at hand. I'm also preparing them for questions they will see years ahead. Internet is a big space. If you need further references, please don't hesitate to find other resources that could supplement what I have just said. Solving equations is a really important topic. In my opinion, it allows us to solve problems that would otherwise require a genius to do. I wish you good luck learning this tremendously useful technique. As always, thank you very much for watching. Please like and subscribe for more maths content and study tips in general. See you soon.